In 1985, scientists discovered something quite shocking beneath Yellowstone National Park. They found a massive magma reservoir nearly 4 miles beneath the surface. It's roughly the size of Los Angeles. But there was something even weirder about it. It had a series of pressure valves that periodically released gas from the magma chamber, making bizarre whistles and whooshing sounds. These features were so strange that they baffled scientists for decades, and we're only just now beginning to understand what exactly they are. The thing is, this discovery raised some very serious concerns about the supervolcano that's been quietly slumbering underneath Yellowstone since the Pleistocene epoch. It's the largest active volcano in the United States, and also one of the most dangerous. If it were to blow, the entire planet would be in peril. So when scientists made this discovery of weird whistling pressure valves in 1985, they tried everything they could to figure out what was going on down there. Yellowstone is a supervolcano. This means that at some point in its history, it produced an eruption that was at least 1,000 cubic kilometers in volume. For comparison, Mount St. Helens, one of the most active volcanoes in the contiguous US, has only had eruptions that are measured in tens of cubic kilometers. By contrast, the most recent eruption at Yellowstone, which occurred between 640,000 and 660,000 years ago, had a volume of about 2,500 cubic kilometers. This blew the top off of its vent and created a caldera, a roughly circular area of land that's lower than the surrounding terrain because part of it collapsed into the magma chamber after the eruption ended. You can still see the remains of this caldera today. It's now called the Yellowstone caldera. It's 43 by 28 miles across and goes down to a depth of 3 miles. The caldera is filled with 3 smaller calderas, each left behind by an earlier eruption. When the smaller of the 3 northern calderas erupted, it blew the top off of the volcano. Then, when the central and southern calderas erupted, they blew the top off of the new larger caldera. Each time the magma chamber gets drained by an eruption, it refills over the next few 100,000 years until it reaches a critical threshold. Then the cycle starts again, and this is what happened in the past. But fortunately for us, it doesn't look like it's going to happen anytime soon. The issue is that these eruptions are extremely difficult to predict. There have only been 3 major ones in the last 2 million years. The last 2 happened hundreds of thousands of years apart, and scientists don't know how long it will take before the next one happens. With no way to know when another major eruption might occur, scientists have focused on studying the smaller events. There are 2 main types of small-scale eruptions that happen at Yellowstone. The first are lava flows that emerge from vents in the middle of the caldera and spread outward like hot honey. The second type involve explosions caused by pressurized magma forcing its way up through weak spots in the Earth's crust. It's the second type that's especially problematic, because while lava flows are slow-moving and easy to track, explosive eruptions can be sudden and unpredictable. As magma rises through cracks in the crust, it can travel along the path of least resistance. Sometimes it breaks through to the surface and creates features like geysers and hot springs. At other times, it finds a blockage that forces it to turn back. And when this happens, the pressure builds and eventually the crust breaks and you get an explosion. These explosions can send blocks of solid rock called tephra into the air. They can also cause hydrothermal explosions, which are blasts of superheated steam and gas. In fact, the most frequently asked question about Yellowstone isn't when will it erupt. It's why does it have so many geysers? Well, it's all thanks to the magma just below the surface. Now, not all explosive eruptions are created equal. Some are relatively minor, but others can be catastrophic. For example, in 1985, an eruption of this kind destroyed a research building in the park. But that's small potatoes compared to the devastation wrought by the 1995 eruption of Mount Pinatubo in the Philippines. That event ejected 15 million tons of ash per second. Eruptions at Yellowstone typically involve far less material. But if they were to somehow get much more intense, they could pose a serious threat to life on Earth. And this is where our story of the mysterious pressure valves comes in. In the early 1980s, scientists were monitoring seismic activity at Yellowstone as part of the Yellowstone Volcano Observatory. They noticed that every few weeks they were hearing a strange whistling sound coming from deep underground, but they didn't know where the noise was coming from or what it meant. Then, in 1985, researchers finally figured out how to record the source of the sound. Using a network of seismometers placed around the park, they were able to identify the epicenter of the whistling, which turned out to be near Norris Geyser Basin, a place known for having many different kinds of geothermal features. Norris Geyser Basin sits near the northern edge of the Yellowstone caldera. To reach it from the parking lot, you need to walk about a half-mile south along a boardwalk that winds past pools of boiling water, hissing steam vents and colorful hot springs. Eventually, you come to a clearing with two large geysers named Excelsia Geyser and the Black Sand Basin. When scientists recorded the sounds they heard here, they were shocked. What they were listening to were the world's largest known magma-driven whistles. They were created by gas being abruptly released from the magma chamber and shooting upward through a narrow pipe. It's similar to what happens when you blow across the top of a bottle. Except instead of air, it's magma, and instead of a bottle, it's a mile-deep pipe. Now, by themselves, these whistles aren't necessarily cause for concern. Scientists have monitored them ever since they were discovered, and they've never become more frequent or more intense. But they aren't entirely harmless either. Here's the thing. These whistles are generated by a release of pressure in the magma chamber. And a sudden drop in pressure means there's suddenly less energy keeping the magma from erupting. So while the whistles themselves are not an eruption, they could be a sign that something more is about to happen. Because of this, scientists have been eager to learn more about what exactly these whistles mean. One theory is that they're evidence of a self-regulating system. See, when magma begins to rise toward the surface, it brings dissolved gases with it. Over time, the pressure of the magma causes the gases to become oversaturated, and this means that the magma can't hold them anymore, so the gas bubbles begin to grow. The growing bubbles create an increase in pressure, which in turn melts more rock and forms more magma, and this leads to even more gas bubbles, which generates even more pressure. It's a positive feedback loop. At some point, the pressure generated by the gas bubbles becomes great enough to overcome the force of the magma pushing them down. And this releases the pressure in the chamber, allowing the magma to rise freely and produce an eruption. The whistling occurs when the gas escapes during this process, and the whistles themselves play a role in regulating the pressure. But the thing is, it turns out that these whistles are actually far more complicated than scientists initially thought. In 2022, researchers were able to record high-pitched whistles from Excelsia Geyser. These whistles, which sounded like a tea kettle, had previously gone undetected because they were too high-pitched for the equipment scientists were using. But here's the thing. When you listen closely, you can hear a second set of lower-pitched whistles layered underneath the higher ones. It's almost like someone took two separate audio tracks, one high-pitched and one low-pitched, and overlaid them on top of each other. But these aren't separate whistles. They're different parts of the same whistle. The higher frequency whistle is created by the actual release of gas from the magma chamber, but the lower frequency whistle is created by the turbulent flow of the gas as it rushes upward. Now it turns out that these two whistles are telling scientists different things about the inner workings of the magma chamber. The lower frequency whistle tells you about the speed of the gas as it moves up the pipe, and the higher frequency whistle tells you about the pressure of the gas in the magma chamber. So by recording both, scientists can piece together a more complete picture of what's happening beneath the surface. For example, by analyzing these whistles, researchers were able to discover that the gas bubbles aren't evenly spaced inside the magma chamber. Instead, they tend to collect in narrow bands. And this gives us insight into how magma moves through the pipes that run through the crust. Basically, it allows the gas to move up in discrete bursts. This explains why we don't constantly hear whistles coming from Norris Geyser Basin. It's not always the case that the pressure drop from the escape of gas bubbles results in an audible whistle. Only when the bubbles reach a certain size and move in a certain way do the whistles occur. So there you go. We've come full circle from obscure seismic recordings to understanding the innermost workings of a supervolcano. Every couple of years, scientists go out to Norris Geyser Basin to record new whistles and compare them to the older ones. So far, they haven't seen any major changes, but they continue to analyze the data in search of patterns. And this is just one more piece in the massive puzzle that is Yellowstone. Because the thing is, there are plenty of other strange phenomena occurring at the park that scientists are working hard to understand. For example, bison and elk have been mysteriously dying in large numbers. Researchers suspect that it may have to do with rising temperatures, but they aren't sure yet. All this is to say that there's no shortage of mysteries beneath Yellowstone, which is good news for people who love weird science. Just ask